Hello students, how are you? I hope all are good. So welcome to Narayan PU college online classes. And previous we have completed organic first chapter, that is haloalkanes and haloates. And coming to the next chapter, second chapter of the organic chemistry, alcohols, phenols and ethers. Clear? And the weightage of this chapter for the PU examination is 8 marks. And one 5 marks question, one question will come for 5 marks. And another one a question for 2 marks. And one 1 mark question. And totally you have 8 marks. 5 marks plus 2, 7 plus 1, 8. Totally 8 marks. Clear? And also very important for the competitive, 1 or 2 questions also will come from this chapter for the CET and mains also. Clear? So first of all, we will discuss what are alcohols and phenols, and after that we will go for the ethers. And alcohols and phenols, how they are obtained. And if you take alcohols and phenols, how they obtained. Yeah. And previous we have discussed and alkyl halides and aryl halides, how they obtained. In the same way, there hydrogen atoms are substituted by the halogen atoms, but in this case hydrogen atoms are substituted by OH group. Yeah. How they obtained here? Replacement of hydrogen atoms. Replacement of hydrogen atom or atoms. Hydrogen atoms. You can say atom or atoms in aliphatic hydrocarbons. Aliphatic hydrocarbons and aromatic hydrocarbons. Aromatic hydrocarbons, and it gives alcohol and phenols respectively. Simple here. Replacement of which one here? Hydrogen atoms in aliphatic hydrocarbons and aromatic hydrocarbons by which group here? OH group. By which group? OH group, and gives alcohol and phenols respectively. Yeah? Simple. You know that here aliphatic hydrocarbons. Take the aliphatic hydrocarbon. Suppose I will take simply here alkane. Alkane is a aromatic hydrocarbon, and replace one hydrogen, one or more than one hydrogen. For simply I am writing here replacement of one hydrogen by OH group. Then what you will get here? CH3 and CH2OH. See here, one hydrogen is replaced by OH group and gives here alcohol, aliphatic alcohol, and simply we can say here alcohols. In the same way, and second one, aromatic hydrocarbons. One hydrogen atom is replaced by the one OH group in the aromatic hydrocarbons, then it gives the phenols. Suppose aromatic hydrocarbon, simply I will take here benzene. You know, benzene is a aromatic hydrocarbon, and hydrogen is replaced by OH group, and here OH group, and you will get here aromatic alcohol and called as phenol. Yeah? And this is, in this one you see aliphatic alcohol, simply we can say alcohol. In the alcohol, the OH group is attached to the sp3 hybridized carbon of alkyl group. This is an alkyl group. So OH is attached to which carbon here? sp3 carbon, and you know how to identify the hybridization here. And this carbon doesn't have any double bond, so that's why it is a which carbon? sp3 hybridized carbon. But you take the phenol. In the phenol, the OH is attached to the benzene ring. Benzene ring means a double bond will be there. So it is a sp2 hybridized carbon. Yeah? And these are how phenols, alcohols and phenols are obtained. They are simply obtained by aliphatic hydrocarbons and aromatic hydrocarbons by the replacement of hydrogens by OH group. Clear? And now, why we have to study about these compounds? Why? Because these compounds, mainly alcohols and phenols, have and wide applications in the industry and as well as in our day-to-day life. Simple example, one is ethanol. You know the ethanol here, CH3, CH2OH, or simply you can write C2H5OH. This is a ethanol. It is used for polishing wooden furniture. Wooden furniture. Clear? And wooden furniture is there, and to polish that one, mainly which compound they will use here? Alcohol. That is mainly which alcohol here? Ethyl alcohol. And another one is sugar and cotton and paper. All these compounds are made up of compounds containing OH group. Compound containing what is OH group. See here, these are sugar, cotton, pepper. All these are made up of which compounds here? Compounds containing the OH. OH means what it is? Alcohols are phenols. So that's why not only this. Nowadays you see, due to the pandemic days of corona, whenever we are stepping out from the home and we are carrying the sanitizers, and sanitizer, it is made up of alcohol, mainly isopropyl alcohol and ethanol. See, so that's why these all are what it is, and applications of alcohols are phenols. Now, ethers, how ethers are obtained? Ethers are obtained by the replacement of hydrogens by alkoxy or allyloxy groups. Clear? Simple. And I will take here compound and CH3, CH3. Alkane I have taken, hydrocarbons I have taken, and replace the hydrogen atom by alkoxy group or allyloxy group. Alkoxy group means RO group we will call as a alkoxy group, and allyloxy means here benzene containing oxygen. This we will call as allyloxy group. Okay? And suppose one hydrogen atom is substituted by alkoxy group, and you will get the ethers ROR. This is a ether. And in the same way, if one hydrogen is substituted by allyloxy group, you will get another type of ether, CH2OAR. This is. Yeah. So what is the ether formula? Ether formula is ROR. ROR. That means one pull one oxygen. If any alkyl groups or any aryl groups or one alkyl, one aryl group is attached, and those compounds we will consider as a ethers. This is how ethers are obtained from the hydrocarbons. And second one is there, and ethers can also be obtained by alcohols. Clear? What is the general formula of the alcohol? ROH. This we will call as a alcohol. If replace the hydrogen atom by the alkyl group, R group, or you can write here aryl group, then you will get the ethers. See, replace here hydrogen. If you replace the hydrogen by alkyl group, and you will get the ether. Or replace the hydrogen by aryl group, then you will also get the which compound here? Ethers. These are how ethers are obtained. Ethers are obtained from the hydrocarbons and as well as alcohols. Clear? And the next one is classification. And here, next concept is classification. Classification of, first alcohol and phenol. and after that ethers classification we will discuss. And the classification of first one is alcohols. So how alcohols are classified? Yeah, and phenols also we will write alcohols and phenols. And later we will discuss classification of ethers. Yeah. So alcohols and phenols, their compounds are classified as mono, di, tri, and polyhydric compounds based upon the whether the compound is having one OH group, two OH group, or three OH groups, or many hydroxyl groups. Simple. And here, suppose compound is containing one OH group, that we will call as a monohydric alcohols, two OH groups, dihydric, and three OH groups, trihydric. Simple. If you take here ethanol, C2H5OH, and this compound is having one OH group, so that's why it is a monohydric alcohol, we can say. Yeah? And if you take here two compounds, suppose compound containing two OH groups, then this compound we will call as a dihydric. Clear? In the same way, compound is containing three OH group, and this we will call as a trihydric. This we will call as trihydric. Monohydric alcohol, dihydric alcohol, trihydric alcohols. And in the same way for the aromatic alcohols also. If on the benzene one OH group is there, and this compound is a monohydric, and if two OH groups are there, it is a dihydric. It is a dihydric. And if three OH groups are there, and this we will call as a trihydric compound. This is trihydric. This is the classification of alcohols, phenols based upon which one here? Number of OH groups present in the molecule. Clear? And the next one, specifically these monohydric alcohols are further classified according to the hybridization. Mainly which one here? Monohydric alcohols. If you take here monohydric alcohols, these monohydric alcohols are further classified according to the hybridization. Classified according to the which one here? Hybridization. According to the hybridization. So what is the one here? One is compounds containing sp3 carbon sp3 OH bond, and second one is compounds containing CsP2 OH bond. This we have to discuss. Yeah. So here classification of alcohol based upon number of OH groups, they are classified as a monohydric, dihydric, and trihydric. And monohydric alcohols further classified into two categories based upon which one here? Hybridization. Based upon hybridization, one is if the compound containing CsP3OH bond and compound containing CsP2OH bond. And later we will discuss what are these. Okay. Now classification. And once first we have discussed based upon the number of OH groups, and second one is based on hybridization. And in this one, first one is compounds containing and CsP3OH bond. CsP3OH bond. This is the first one. Okay. So means what does it mean? In these compounds, the OH is attached to the sp3 hybridized carbon of alkyl group. OH is attached to sp3 hybridized carbon of alkyl groups. And you know, previously we have discussed in this one, first one is alcohols. You know that in the alcohols, the OH is attached to the sp3 carbon of alkyl group, sp3. Okay, so alcohol, because you know in the alcohol the OH is attached to the sp3 hybridized carbon of alkyl groups, and you know best example I will write here, alcohol, ethanol. In this one, the OH is attached to this carbon, CH2 carbon. You know this carbon is a sp3 hybridized carbon. So that's why, and this compound is having CsP3OH bond. And these compounds, alcohols, are further classified into three categories. One is primary alcohols, and second one is secondary alcohols, and tertiary alcohols. Clear? So what is primary alcohol? Means you know in this one OH group is attached to the CH2, then that alcohols we will call it as a primary alcohols. OH is attached to which one here? CH2, and those alcohols we will call as a primary alcohols. And if OH is attached to the CH group, then those compounds we will call as a secondary alcohols. OH is attached to which one here? CH, and OH is attached to CH2. CH2 means primary, CH means secondary. And if OH is attached to the only the carbon not having the hydrogens, and those alcohols we will call as a tertiary alcohols. Clear? And simple example, if I write here CH3CH2OH, which alcohol here? Primary. Why? Because OH is attached to which one? CH2 group. If I write this is CH3 and CH3OH, and this is a secondary alcohol because you know OH is attached to CH group. And if I write this is CH3OH, and this compound we will call as a tertiary alcohol because OH is attached to the carbon, doesn't have any hydrogen atom. So this is the classification of the primary, secondary, and tertiary of alcohols. And in this category, second one is allylic alcohols. Second one is what it is? Allylic alcohols. And you know previous in the halo alkanes and halo arenes we have already discussed what is the allylic carbon. Clear? So what are the allylic alcohol means? In this alcohol, OH is attached to the sp3 hybridized carbon next to the double bonded carbon. You see, suppose if I write here CH2 double bond CH and CH2OH, this we will call as a allylic alcohol because you know, and here double bonded attached sp3 carbon we will call as a allylic carbon. To the allylic carbon OH is added bonded, so that's why that alcohol we will call as a allylic alcohols. Yeah? What are the allylic alcohol? The OH is attached to the sp3 hybridized carbon next to the double bonded carbon. This group is called as allylic group, and this is allylic alcohols. And in this also, which bond is there here? This carbon is which carbon? sp3 hybridized carbon, so that's why OH is bonded to the CsP3. So allylic alcohol also comes under the category of compound containing the sp3OH bond. Clear? And these are also again three types. You know, one is primary allylic alcohol, and the second one is alcohol, and second one secondary allylic alcohols, and the third one is tertiary allylic alcohols. Same how we have classified alcohols into primary, secondary, and tertiary in the same way. In this one, what happens? You see, if I write CH2CH, CH2OH, OH is attached to which group here? CH2 group. So it is a, but here this group is a allylic group. So that's why it is a primary allylic alcohol. And if I write here secondary, CH2CH and CH, suppose if I write CH3 OH, and you know this is a allylic group, and to the allylic group OH is added, allylic alcohol, but this is attached to CH, so that's why it is a secondary allylic alcohol. In the same way, and this is CH2 CH and CH3 CH3 OH. This is a OH is attached to the carbon not having the hydrogen, so that's why it is a tertiary allylic alcohols. Yeah, and this is the second category in the sp3OH bond. And third one is benzylic alcohol. Third one is benzylic alcohols. Yeah, you know that what is the benzylic alcohol? Benzylic carbon, you know what is the benzylic alcohol? In this compound, in this alcohol, OH is bonded to the sp3 hybridized carbon next to the benzene. Next to the benzene ring. Simple. And take the here benzene ring and here CH2OH. As we have already discussed in the previous chapter, when sp3 carbon is attached to the benzene ring, and that carbon we will call as a benzylic carbon. So that's why to that benzylic carbon OH is added, so we will call this is a benzylic alcohol. What are the benzylic alcohol? In this alcohol, OH is attached to the sp3 hybridized carbon next to the benzene ring. This would be called as a benzylic alcohol. Same classification, same here, primary, secondary and tertiary. Primary benzylic alcohol and secondary benzylic alcohol and tertiary benzylic alcohol. Clear? You know that primary benzylic alcohol means, what are the examples? Primary benzylic alcohols. You know in this one, simple, and here CH2OH. This is a benzylic and OH is attached to CH2, so it is a primary. What about the secondary? Secondary benzylic alcohol means what we have to write? And CH3OH. This is a which one? Secondary. And this is benzylic and secondary because OH is added to CH, so it is a secondary benzylic. What about the tertiary? Tertiary benzylic alcohol. What are the examples of this one? C and here CH3. If you write CH3 and OH, and this is a benzylic, this is, and this is a tertiary. OH is attached to the carbon not having the hydrogen, so it is a tertiary benzylic. This is the classification of which one here, and based on hybridization, compounds containing the sp3OH bond. If you take in the alcohols, in the allylic alcohols, in the benzylic alcohols, OH is attached to the sp3 carbon. Next one, first classification we have completed, compounds containing sp3OH bond, and second one is compound containing CsP2OH bond. What does it mean here? CsP2OH bond means OH should be attached to the double bonded carbon. Double bonded carbon, you know what is the hybridization of double bonded carbon? sp2. So that's why OH should be added to the double bonded carbons. And these are mainly two types. One is vinylic alcohols, and this is also what are the vinylic group we have already discussed in halokines and alkynes. Yeah. So what is the vinylic group? CH2 double bond CH. This group we will call as a vinylic, and to this OH is added, and that compound we will call as a vinylic alcohol. You see here, OH is bonded to the carbon. This carbon hybridization is sp2. So that's why we will call compounds containing and sp2 CsP2OH bond. And if you take another example, this is also, and if I write here OH, this is also which one here? Vinylic alcohols. And here double bond. To the double bond, OH directly added. This carbon is which carbon? sp2 hybridized carbon. Yeah. And in this one, what are the vinylic alcohol means? in this one OH is directly bonded to the double bonded carbons, and that double bonded carbon and those alcohols will be called as a phenylic alcohols. And second category in this CsP2OH bond is phenol. Next one is phenol. You know phenol and monohydroxy derivative of benzene we consider as a phenol. In this phenol, OH is added to, we can write in this way also, right? And here OH, and OH is added to double bonded carbon, so that's why sp. If it is benzene, then we call those compounds as a phenol. If it is not benzene, OH is directly attached to the double bonded carbon, those we will call as a phenylic alcohols. These are the classifications of which one here? Alcohols and phenols. Clear? Next one is classification of ethers. Next one is classification of ethers. So we have completed classification of alcohols and phenols. Now we are going to discuss about classification of ethers. Yeah? And ethers are classified into two categories. One is simple ethers, or we can say simple or symmetrical ethers. Simple or symmetrical ethers. Okay? And you already know what is the ether formula, O general formula, R, O, R dash. Okay? What are the simple or symmetrical ethers means? If both the alkyl groups or aryl groups are same, attached to the oxygen atom are same, and those ethers we will call as a simple ether. Suppose if I write example CH3O CH3. Yeah? And to the oxygen, both the alkyl groups are here same, so that's why this we will call as a simple ether or symmetrical ether. Another example if I write here PHO and pH. This is also which ether? Symmetrical ether or simple ether. Why? Because to the both sides of the oxygen the groups are same. In the same way, second one is here, second one, and mixed ethers. Mixed ethers are, you can say, unsymmetrical ethers. Mixed ether are unsymmetrical ethers. Yeah. So what are the mixed one means? And the groups which are attached to the oxygen atoms are different. Same means simple or symmetrical. Difference means mixed or unsymmetrical. Suppose if I write CH3O, C2H5. Here one is methyl group and another one is ethyl group. Both are different groups. So these ethers we will call as unsymmetrical ethers or mixed ethers. Or you can write here CH3O, pH. These are, one is CH3 and another one is pH. Both groups attached to the oxygen are different. So that's why we will call these are mixed or unsymmetrical ethers. Yeah. So this is about the classification of what it is, alcohols, phenols and ethers. Next one is nomenclature of alcohols. So here we will discuss in this common name and also IUPAC name. Yeah. So what is the common name of alcohols? Yeah. So the common name first we will write here, and after that IUPAC name, and this is for monohydric alcohols. I am writing first of all monohydric alcohols. You know what does it mean? Monohydric alcohols means the alcohol or the compounds contain alcohol containing only one OH group. What is the common name for that? Yeah? The common name of monohydric alcohols are alkyl alcohols. Alkyl alcohols. Yeah? And what is the IUPAC name for this is, alkanol. This is alkanol. This is the common name and IUPAC name. Yeah? And second one, dihydric alcohols. For dihydric alcohols, you know what is the common name and IUPAC name. The common name for dihydric alcohols are, you know, alkene. The common name of dihydric alcohols are alkene glycol. What it is here? Alkene glycol. And IUPAC name of these compounds are, you know, alkene diodes. Alkene diodes. This is for common name and IUPAC name. And very important thing is here, glycol means the OH, two OH groups are adjacent to each other. Means two OH groups are present to the adjacent carbons only. And further one, we will write alkene glycol, common name. If not adjacent, OH groups are not adjacent, then what is the common name for that one is polymethylene glycol. Polymethylene glycol. This is important. I will write some examples here. Then you will understand easily what is the meaning. One OH, two OH groups are adjacent to each other. What is the common name? Alkene glycol. If the OH groups are not adjacent to each other, then we will call that is polymethylene glycol. Clear? And this is IUPAC name means what it is? Alkene diodes. And in the same way, trihydric alcohols. If you take the trihydric alcohols, what is the common name? The common name for these compounds are, you know, glycerols. The common name is glycerol. And IUPAC name for this compound is, same here, alkene, and here alkane, not alkene here, alkane diodes, and here also alkane trichodes. Alkane trichodes. Yeah? And see here, simple example I will give. Suppose if you take CH2CH2OH. This is which alcohol? Dihydric alcohol, and both the OH groups are adjacent to each other. Means OH present adjacent carbons only. And what is the name of this compound is? What is, how many carbons are there? 2 carbons. So that's why we will write ethylene glycol. We will write here ethylene glycol. And same compound I will write here. Another one compound CH2CH2 OH and OH here. See here, this is also dihydric compound, but OHs are not present on adjacent carbon. Here both the OHs are present adjacent carbon, but here OH is present on the first carbon and another OH is present on the third carbon. For this one, how to give the name? And that is polymethylene glycol. You have to give the name. Means how many methyl methylene groups are there? 3. Trimethylene glycol means trimethylene glycol. This is important. You have a common name, you have to remember. You understand what is the difference here? Alkene glycol and polymethylene glycol. Two OH groups are adjacent, and then alkene glycol. Not adjacent, polymethylene glycol. Now, in the NCERT textbook one table they have given of the IUPAC name and common name of alcohols, that I am going to write here. So here, common name and IUPAC name table. So in the NCERT textbook they have given. Yeah? And you know, these are alcohols. What are the common name for the alcohol? We have already discussed. Alkyl alcohol. Means we have to first write the alkyl group and after that alcohol. What is the alkyl group here? Methyl. So that's why. What is the name of this compound? Methyl alcohol. This is methyl alcohol. What is the IUPAC name? IUPAC name I already mentioned. What is the IUPAC name? Alkanol. Clear? So what we have to write? What is the alkyl group here? Methyl. So that's why methanol. OL we have to add with the OL. In the same way, you know, this is a propyl group. And this is propyl group, so that's why we have to write propyl alcohol. 3 carbon atoms are there, propyl alcohols. And what is the IUPAC name here? You know that while writing the IUPAC name, you have to choose the longest parent chain, carbon chain, and this is the longest carbon chain, and you have to give the numbering from the end to get the OH attached carbon least number. So that's why you should start the numbering from here. Clear? So it is a propane. You can write here propanol. Propane, or you can write 1 mole, because OH is attached to which carbon? First carbon, so that's why propane 1 mole. In the same way, you know this group, previously we have already discussed CH3, this is the group, you know, CH3 and CH3 group we will call as a iso group. And how many carbon atoms are there? 3, so that's why isopropyl. See here CH3, CH. And to this CH, here OH is added. So that's why this group we will call as an iso, and 3 carbon atoms are there, so that's why we will call it isopropyl. So this we will write here isopropyl alcohol. This we will write here isopropyl alcohol. You know how to write the IUPAC name? Alcohol, we have to first select the longest carbon chain and give the numbering in a such a way that to get the OH attached carbon least number. So 1, 2, 3. Clear? So that's why. What is the name of this compound? How many carbon atoms are there? 3. 3 means what it is? Propane. So that's why propane 2-ol. OH is attached to which carbon? Second carbon. So that's why 2-ol. In the same way, and here 4 carbon atoms are there, we will call it is N-butyl alcohols. N-butyl alcohol. In the same way, and 4 carbon atoms, give the numbering in the 1, 2, 3. OH attached carbon should get the 1. So it is a butane 1-ol, or you can write butanol also, no problem. And second one is, and here these carbons, this is a primary carbon, this is a primary carbon, this is secondary, and this is secondary. Clear? So OH is attached to which carbon? Primary carbon. Clear? So that's why. So OH is attached to which carbon? Secondary carbon. So that's why this is a secondary. How many groups are there here? Carbons. 1, 2, 3, 4. So that's why secondary butyl alcohols. This is secondary butyl alcohol. And now we have to write the IUPAC name and select the longest chain and give the numbering from here 1, 2, 3, 4. OH should get the carbon should get the least number. So what it is here? Butane 2-ol. This is the IUPAC. And second one, you see here, very important in this one. This is CH3. This group we will call as a, you know, iso. But in this iso, total here in this compound, how many carbon atoms are there? 1, 2, 3, 4. So that's why we will call this is isobutyl alcohol. Iso group is there, so that's why iso. How many carbon atoms are there? 4. So that's why we will write here isobutyl alcohol. This is the name of the common name. And while you are writing the IUPAC name, what you have to write? Choose the longest carbon chain and give the numbering 1, 2, 3, because OH carbon should get the least number. And here on the second carbon, which one is there? Methyl. So that's why 2-methyl and propane 1-ol. 2-methyl, 3 carbon atoms are there. What would be like? Propane. Ol is present. Alcohol is present on which carbon? First carbon. And you know this group is a tertiary group. CH3. This group we will call as a tertiary. So that's why it is a tertiary. How many carbon atoms are there? 4. Tertiary butyl alcohol. Now you have to select the IUPAC name. While you are writing the IUPAC name, first you have to select the longest carbon chain. This is the longest. 1, 2, 3 you can select. 1, 2, 3 you can select. This is the longest carbon chain. Give the numbering. 1. This carbon is 1, this is 2, and this is 3. So on the second carbon, CH3 is there and OH is there. So that's why 2-methyl. Total how many carbons are there in the parent chain? 3. 3 means what we have to write? 2-methyl propane 2-ol. OH is present on which carbon? Second carbon. 2O. And you see, this I already mentioned here, trihydric alcohol. It is a which alcohol? Trihydric alcohol. What is the common name here? Glycerol. The common name of this one is glycerol. Yeah? And you know how to write the IUPAC name? I already mentioned alkane triols. Alkane triols. Here 1, 2, 3. Here on the first carbon OH, second carbon OH, and third carbon OH. How many carbons are there here? 3. So that's why you have to write here propane. You have to write N. Ne you have to write. You should not remove here like how we have removed E here. And propane 1, 2, 3. 1, 2, 3. Because 1 carbon, second carbon, third carbon OH groups are there. 3 OH groups are there. We will write as triols. Okay? And this is, we don't have the common name. And you know cyclic compound, cyclo. How many groups are carbon atoms are there? Cyclohexane. So that's why you know 1, 2, 3. If you write cyclohexanol, hexanol, or cyclohexane 1. And this is you see 1, 2. So what you have to write here? 2-methyl. Cyclohexane. These are the what it is IUPAC names and common names of the alcohols. Next one is IUPAC nomenclature of aromatic alcohols. Yeah, and the first one here for monohydric alcohol, aromatic alcohols, the common name and IUPAC name is same. So what is that one is phenol. This is only the common name and this is also the IUPAC name. Okay? But when we are coming to the, and if phenol is having any substituents, so then same, you know, phenol name only will come. But what is, how to identify common name and IUPAC name? And common name means we will write the ortho, or meta, or para. That is the common name. If you write the numbers indicating the positions 1, 2, 1, 3, 1, 4, then it is IUPAC. Simple. Clear? And here if I write here common name, what I can write common name? For the OH, this position is ortho position, this is the meta position, this is the para position. This is the ortho position, meta position, para position. What is the common name here? Orthomethyl. Orthomethyl. You know what we can call this is phenol. Orthomethyl phenol. Clear? What is the IUPAC name here? This is 1, this is 2. Phenol we have taken. Phenol means OH is included. So that's why the carbon you have to give the number 1. So 1, 2. So that's why 1, 2. You can write here 1. This is orthomethyl phenol. And what is the IUPAC name here? Methyl is present on which position? Second position. So you will get the 2-methyl phenol. Means if number is there, IUPAC name. Ortho is there, common name. Here also you can write here methyl phenol. Clear? And also we can write 1, 2, 3. 1, 2, 3. And you know 3-methyl phenol. 3-methyl phenol. Same here, it is a para-methyl phenol. Para-methyl phenol. And it is a 4-methyl phenol. IUPAC name is which one? 4-methyl phenol. But these compounds have trivial names. Those are only nowadays considered as a common names. So this on the phenol, if CH3 group is present, means on the benzene CH3 group is there, and that compound we will call as a cressols. Clear? This is the phenol. On the phenol CH3 group is present, then we will consider that one as a cresol. It is ortho position. We will write here ortho cresol. And this is which position? Meta cresol. And this is para cresol. These names nowadays are considered as a common names also. Trivial names only nowadays using as a common names. Yeah. And the second one is dihydric aromatic alcohols. Very important. Like previous we have discussed for the aliphatic. alkane diodes. Same here, benzene diodes. What is the IUPAC name here? Benzene diodes. And here common names. First we will write here common name. What is the common name here? And that is a trivial names are there, and that we will consider as a common name. IUPAC name is there and common name. First I will write IUPAC name. So you know benzene you have to write. On the benzene 1 and 2 position, which one is there? OH groups are there. So what is the IUPAC name? Benzene 1, 2 diode. Like, and you know glycol we have discussed. Clear? In that way. So here in this one, 1, 2, 3. You know benzene 1, 3 diodes. Clear? In the same way here, benzene 1, 4 diodes, because 2 OH groups are there. Diodes. Simple. Previous I have mentioned using CH2OH. What is the name of this compound? Dihydric compounds. So what is the name? Ethane diodes. 1, 2 diodes. In this one, ethane. Here which one is there? Benzene. That's it. So what is the common name for this one? And common name is, we will call this one as a catechol. Remember, when on the benzene ring 2 OH groups are present at 1 and 2 position, that is a catechol. And OH groups are present on the benzene ring at 1, 3 position, resorcinol. Clear? And both are 1 and 4 position, hydroquinone. So this is about the IUPAC name and common names. Next one is IUPAC name and common names of ethers. Yeah. So first of all, what is the common name and what is the IUPAC name? And after that we will go for the answer textbook table. Yeah. And common name while you are writing. Suppose you know what is the functional means the common general form of ether is ROR. We can write. Yeah. So you have to write the first common name. First you have to write the groups which are attached to the oxygen. We have to write the name of groups which are attached to the oxygen in an alphabetical order. And followed by you have to write the term ether. Suppose here CH3, suppose if I write CH3O, C2H5. What is the common name? First we have to write the groups attached to the oxygen. Here methyl and here ethyl. Which comes first in the alphabetical order? Ethyl. So that's why methyl ether. That is the name. But what is the IUPAC name is alkoxy alkane. This is name alkoxy alkane. And very important, while writing the alkoxy alkane, the O should be taken to the smaller alkyl group. The O should be taken to the which one? Smaller alkyl group, and that we will consider it as a alkoxy. And the larger group will be a part of alkane. Suppose if you write the name of this compound, and this is CH3 and here it is C2H5. This is CH3 smaller group than the C2H5 because here 1 carbon and here 2 carbons. So this we will consider it as a, it should be with the oxygen. So this we have to write as a alkoxy and this we have to write as a alkane. Larger group we have to write as a alkane and smaller group should be with the oxygen, should be written as a alkoxy. So methoxy ethane, because it is methoxy and here 2 carbon alkane, what we will call it? Ethane. So based on this we will write the, and here common names and IUPAC name of ethers. So we can write here alkyl ethers. This is the common name. Okay? Now you see, in this one, first one, alkyl ethers is the common name. So here which one is there? Methyl groups. How many are there? 2. So that's why dimethyl ether. Dimethyl ether. Here the name we have to write. Next one. What is the IUPAC name here? IUPAC name what I have mentioned? Alkoxy alkane. But both groups are same. So that's why any one we can take as a alkoxy. Methoxy here one carbon alkane, what we will call methane. So that's why methoxy methane is the name. Clear? And second one, here also C2H5. So same alkyl group, so we have write di. So what we have right here, diethyl ether. This is common name. So here ethoxy, we can write here alkoxy means RO group I mentioned. So ethoxy ethane. So we can write here ethoxy ethane. That is the impact. Come, if you see the third one, we can understand what is the exact name here. Now you see, and polar oxygen, one is CH3 and another one is propyl group. Here one carbon, three carbon. Small one always should be with the oxygen. Clear? So that's why you have to take this one as an alkane. While you are taking as an alkane, you have to do the numbering. So numbering 1, 2, 3 should be started. Yeah. So what we can write here? This OCH3 is added to first carbon. So that's why we can write first impact name here 1-methoxy. 1-methoxy. 3 carbon atoms are there. What we can write? Propane. 1-methoxy. Yeah. So what is the common name here? Methyl. It is propyl. Which comes first in the alphabet ladder? MNOP. So methyl comes first here. So that's why methyl propyl ether. Methyl propyl ether. This is the item. Now you see here. Here C6H5 and here CH3. Benzene ring here. How many carbons? 6 carbons. But here 1 carbon only. So that's why it is a small group. It should be with the oxygen. So methoxy benzene. What is that name here? Methoxy alkane, alkoxy alkane. It is a benzene. Yeah. Now common name methyl phenyl. So methyl comes first. Methyl phenyl ethers. Methyl phenyl ether. Same thing also. 6 carbons, 2 carbons. It is small, so that's why we have to write ethoxy benzene. So the name here is ethoxy benzene. But if you write the name, it is a ethyl. It is a phenyl. So ethyl comes first here. Ethyl phenyl ether. Important thing is here on the benzene ring. This is what I can write this compound OCH3. This is the compound. C6H5 means what it is? Benzene ring. On the benzene ring, which one is there? OCH3. This compound we will call as a anisole. What we will call this is anisole. On the benzene ring, OCH3 group is there. That is a anisole. That can also be a impact name also. Anisole. Yeah. And here on the benzene ring, ethyl group is there. On the benzene ring, ethyl group is there. That we will call as a phenol. That is the common name. And next one. See here, in this one side, carbon, how many carbon atoms are there? 6. But here, how many carbon atoms are there? 7. Because CH2 6 times and C. So that's why 7 carbon atoms are there. And which one is the small one here? 6 carbon atoms. So that's why you have to write the name. You have to write the name here, phenoxy. Here, and you know here 6 carbons and here 7 carbons. So that's why 6 carbon one should be considered as a small one. So that's why what we can write here, and 1-phenoxy heptane. 7 carbon atoms are there. Heptane. 7 carbon atoms are there. Heptane. What is the common name here? And phenyl. Heptyl first we have to write here. Heptyl phenyl. Next one. See this one. And you know in this compound, and first one is CH3, and here how many carbon atoms are there? 3 carbon atoms. So that's why you have to write here methoxy. And first you have to take this one as an alkane. Alkane when you are taking, you have to do the numbering. Numbering should be starts from the end only. 1, 2, 3. So methoxy is added to which carbon? Second. So that's why 2-methoxy propane. 2-methoxy propane. Yeah. And here this is the propyl group and this is a methyl group. MNOP. So that's why methyl isopropyl you have to write. Why? Because it is not a propyl group. Here this is CH3 so that's why methyl isopropyl ether. In the same way, here how many carbon atoms are there? 4. Here 6. So that's why it should be considered as a alkoxy. So give the numbering 1 because no attached one you have to give numbering 1. 1, 2, 3, 4. Clear? So now what you have to write the name here? You have to write the name. First oxy you have to write. What is the oxy here? 3-methyl. 1, 2, 3, 4 butoxy. 3-methyl butoxy. What you have to write here? Benzene. This is the name. And next one. And you see here 2 alkoxy groups are there. So when you are writing the 2, you have to write this is 1, 2. And here 1, 2 dimethoxy. Ether, how many carbon atoms are there? 2. So that's why ethane. Yeah. So that's why first which one is the small and which one is the bigger one you have to see. And small one has to write as a alkoxy and the bigger one is, or you can say larger compound can to be written as a alkane. Now come to this one. And alkyl group, so this is cyclic compounds, will not have any common names. And in this one is here, in this 6 carbon atoms are there and here 2 carbon atoms are there. Well, on one side 6 carbons and the other side 2 carbons. So what you have to do? And you have to write this one as a alkoxy. But very important here giving the number. Numbering, how to give? Suppose if I give numbering 1 and 2 here, then see the sum of the locates here. 1 and 1, 2 methyl groups are there. 1, 1 and here 1, 1 and 2. 1 plus 1, 2 plus 2. It is a 4. If you give numbering from here, this is 1 and this is 2. Then what you get? 2 dimethyl and here 1. 2, 4 and 5. So from which side you have to give the numbering? You have to see the sum of the locates. Clear? So that's why you have to give the numbering from 1 and here 2. So what you have to write the IUPAC name here? 2-methoxy. 2-ethoxy. And you have to write 1, 1 dimethyl cyclohexane. Coming to the second one. Previous year how many CH3 substituents are there? 2. But here how many? 1. If I give numbering 1 and 2, 1 plus 2, 3. If I giving numbering from here 1 and 2, here also 1 plus 2 is equal to how much? 3. Same only. When locates are same, you have to give the numbering according to the alphabet order. Here what you will get? Ethoxy, E. And here what you will get? Methyl. Which one comes first in the alphabetical order? E. So that's why you have to give the numbering from this one. Previously you see here 1, 2. But now 1 we have given to the ethoxy and 2 we have given to the methyl. So what is the IUPAC name here? 1-methoxy. 1-methoxy. 2-methyl cyclohexane. 2-methyl cyclohexane. Clear? This is also in the same way. 1, 2, 3, 2, 1, 3. Ethoxy, nitro. So that's why 1 and 2. 1 ethoxy. 1 ethoxy. And here 2 nitro cyclohexane. So these are the common and IUPAC names of